Now we're going to look at cyclic quadrilaterals. Opposite angles in cyclic quadrilaterals are supplementary, which means they add up to 180 degrees. And just a reminder, a cyclic quadrilateral has all four vertices sitting on the same circle. What this theorem means is that A plus C is equal to 180 degrees and B plus D is equal to 180 degrees. Let's try and prove this now. I'm going to start by connecting some lines here in this quadrilateral to make a couple of triangles. I'm going to connect these lines here and these points here. And to make it easier for the proof, I'm going to number these angles. So this will be angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. I'm just going to type up a bit of a statement now. The following angles are equal as they are circumference angles subtended by the same arc. That's actually the previous theorem we're going to use primarily for this proof. So there's a few that we're going to state here, which is why I made a bit of a blanket statement as opposed to writing this out a lot. We're going to start off with angle ADB, which is this angle 5 in here. So angle ADB, based on this rule, will be equal to angle BCA, so angle 8 here. Why? Because these are both circumference angles subtended by this arc AB, so they are going to be equal to each other. This will apply for pretty much all of the angles around with each of these arcs, arc AD, DC, BD, AB. So I'm going to write the rest of them up now. Angle BAC is equal to angle BDC. Angle CAD is equal to angle DBC. Angle ABD is equal to angle ACD. And I'm just going to now, in a different color, write down the numbers that we've used to represent each of these angles. So this will be angle 5 is equal to angle 8. Angle 1 is equal to angle 6. Angle 2 is equal to angle 4. And angle 3 is equal to angle 7. So let's keep moving. So the angle sum of a quadrilateral is equal to 360 degrees. So that means that angle DAB plus angle CBA plus angle BCD plus angle CDA will equal 360 degrees. As you can see, each of those angles are represented by 8 numbers. So I'm going to rewrite this statement using our 8 numbers. So angle 1 plus angle 2 plus 3, 4, 5, 6, 7, 8 is equal to 360 degrees. But what you can see up here is we've just shown that each of these angles is actually equal to another angle. So instead of using every number, we can just use half of the numbers and multiply them by 2. So 2 times angle 1 plus angle 2 plus angle 7 plus angle 8 will be equal to 360 degrees. Now, some simple algebra here. I'm going to divide by 2, so this will cancel out. So I have angle 1 plus angle 2 plus angle 7 plus angle 8 is equal to 180 degrees. Now look at angle 1, angle 2, 7 and 8. Up here, angle 1 and 2 is this angle DAB. 7 and 8 is this angle BCD. So what we can now say is that angle DAB plus angle BCD is equal to 180 degrees, which is what we have up here. The same would work for if we chose different numbers. So this angle ADC and angle ABC. So now let's have a go at a few examples of using these circle theorems to find unknowns. In this question, we're asked to find x, and we have been given some information over here. Now we know that this angle here is going to be equal to 110 degrees because it is a vertically opposite angle to this one, which is 110 degrees. And we know that this angle here is going to be equal to 27 degrees. And that is because it uses that theorem of angles subtended by the same arc at the circumference are equal. Circumference are equal. So it's going to be the same as this angle here because they're both subtended by this arc. So that means we have in this triangle 110 and 27, and we need to find x. And we know the angle sum of a triangle is 180 degrees. So I'm just going to go 180 minus 110 minus 27 to find x, which will be 43. So x is equal to 43 degrees. Let's move down to this next example. This is asking us to find angle 0 OAB. So OAB is this angle here. So what information have we been given? We've got some information about these angles up here. And we know that the angle at the center is twice the angle at the circumference. So we're just going to write that down. Angle at the center equals 2 times angle at circumference, which means that this angle AOB equals 2 times angle ACB. And angle ACB is going to be 12 plus 25. That'll be 37 degrees. So angle AOB will equal 2 times 37, which is going to be 74 degrees. Now, this distance from the center to the circumference and this center to the circumference here is going to be equal because they'll be the radii. So AO will be equal to BO because they are radii. That means that triangle AOB equals an isosceles triangle. Okay, oh, sorry, it's a bit messy. If it's an isosceles triangle, that means that angle OAB must be equal to angle OBA, and they both must be equal to, if the angle sum of a triangle is 180 degrees, 180 minus this angle that we've already found, 74, and then divide by 2 so that we have the two angles. So each angle will be 53 degrees. And does that answer our question? We were after angle OAB. OAB is 53 degrees.